at will at any time you wish. Now, starting the presentation of posters, I'd like to invite on stage Sibele, Andrade, Roberto for the first poster presentation. She will present the poster Breaking Barriers in HTLV1 Diagnosis, VHH Anti P24 Antibodies for the construction of efficiency, optical, electrochemical, biosensors.
Bom dia.
Good morning. I'm Sibele Andrade. I'm the PhD program student in the program at Fiocruz Rondônia, and I'll present to you the study called Breaking Barriers to an HTLV and Diagnosis. Well, you see the title on the screen. It's important that we talk about the HTLV virus. Have you heard of this virus? This virus it belongs to the Delta retrovirus family. It's associated with two high morbidity and fatality illnesses, leukemia of T cells in adults, and myelopathy related to HTLV, also called tropical brady's. We estimate that about 10 to 15 million individuals are infected with the HTLV virus. However, in Brazil, the data are underreported, because the compulsory reporting has become mandatory in February 2024. However, with a view to developing screening methods to cater to the needs of the population to screen some infections by HTLV, new platforms are being looked into. But after all, what are nanobodies or VHH? The animals of the camelide family produce, in addition to conventional antibodies, they produce heavy chain antibodies called nanobodies. And these nanobodies have physicochemical properties that lead to their use in the construction of inputs, sensitive and specific and stable inputs. And therefore, the goal of this study was to develop an input that's applicable to the detection of the infection by HTLV1 through the development of antibodies of the VHH type. That's the immunoreactive but important marker of the infection by HTLV, which is P24 protein. We have used two strategies: the building of a optical biosensor and the construction of an electrochemical biosensor. To build the optical biosensor, we did the synthesis of the bolt particles and their bioconjugation with the VHH. Once we obtained a stable bioconjugate, we then assessed it against its immunoreactivity to V24. And the second strategy was the building of an electrochemical sensor, where this nanobody was immobilized, and gold electrodes and all the stages of characterization were undertaken through electrochemical techniques. The construction of the optical biosensor was carried out by determining three parameters: concentration of stabilizer, concentration of VHH, and pH. And to assess the stability of this bioconjugate, we undertook an aggregation assay with the addition of a ionic disturber, which was the NaCl, and the ideal condition was considered vis-a-vis the lowest displacement of the wavelength. And the assay of stabilizer concentration, we noticed that before the aggregation assay with the addition of NaCl, the conjugates featured characteristics of wavelength between 500 and 520 nanometers. When we added NaCl, the lowest displacement took place in 75 millimolars of the stabilizers, with a displacement of 56 nanometers. With the pH assay, we noticed the same behavior. All the bioconjugates featured nanoparticles in the wavelength of 500 to 520 nanometers, and we added NaCl. The lowest displacement took place in pH 9 with 67 nanometers. Once we ascertained the concentration of stabilizer and the ideal pH for this bioconjugation, we undertook the concentration assay for VHH, where we noticed after the assay stability assay that the concentration of 6 and 8 micrograms featured the lowest displacement. However, the concentration of 8 micrograms led to the displacement of just 1 nanometer. Once we obtained this biosensor, stable biosensor, it was then assessed against its immunoreactivity through data, and we were able to observe that this biosensor was able to recognize the P24 protein in the range of concentration of 400 to 415 nanograms per liter, which highlights the absence of reactivity, cross-reactivity against other antigens like the P24 protein of the HIV virus type 1. And the attempt to increase the sensitivity of these biosensors, we built an electrochemical biosensor from the immobilization of this nanobody and the gold body, and all stages of characterization led to the reduction of the current, which is the characteristic of this kind of biosensor. And when we assessed the capacity for detection of this P24 protein, we noticed a proportional increase between the increase in concentration of the P24 protein with an increase in the current. And in this biosensor, we were able to detect 1 nanogram per microliter of the P24 protein. Therefore, results obtained demonstrate that the VHH nanobodies against P24 can be used for the production of inputs, since these optical electrochemical sensors had the ability to recognize the P24 protein, respectively, in 15 and 1 nanograms per microliter.
Perspectivamente, nós pretendemos.
And the perspectives is that we can assess the capacity of these biosensors, and we can identify P24 protein in the treatment in these infections. So I thank you all to the Laboratory of Antibodies Engineering, Fiocruz, and other institutes and the organizer. Thank you very much.